Hello friends, myself Rajendra Mahajan presenting my video on Heaviside unit step function and displaced Heaviside unit step function from Laplace Transform. First of all, we define unit step function. It is defined as h of t is equals to 0 for t less than 0, and its second value is 1 for t greater than or equals to 0. Therefore, once again, h of t is equals to 0. First value is 0 for negative values of t, and for positive values of t it is equals to 1. This is the definition of that unit step function, and it is denoted by either h of t or u of t. H stands for Heaviside and u stands for unit step. Therefore, we can use any symbol to represent this unit step function. The same we can represent by means of figure. On x-axis we take the values of t, on y-axis we take the values of f of t, and this is the line parallel to x-axis at 1. The value of y is 1 here, and this graph represents h of t. For negative, its value is 0, and for greater than or equal to 0, value is 1. And then we find Laplace of h of t as 1 by s. Then second, displaced unit step function or Heaviside displaced unit step function. It is defined as h of t minus a is equals to, again there are two values for this function also. The first value is 0 for t less than a, and second value is 1 for t greater than or equals to a. And this is, we can denote by means of figure like this. Again, t and f of t, on x-axis t and on y-axis f of t, and graph starts from t is equals to a, value is 1, and for other values of t, value is 0. Therefore, from a onwards towards right hand side, value is 1, and towards left hand side it is 0. Therefore, this is the graphical representation of that displaced unit step function, denoted by h of t minus a or u of t minus a, and then its Laplace transform is e raised to minus as whole divided by s. Then, after definition of these two important terms, we take a multiplication of a continuous function f of t by unit step function h of t, and we use the help of, we take the help of values. H of t first value is 0 for less than 0, therefore product becomes 0, and for another value it is 1 into f of t, we get f of t for t greater than or equals to 0, and then we represent it by means of figure. There are two figures, first one for f of t, second one for unit step function. Therefore, f of t is a continuous function like this. Points are a, then b, c, d and e. These are the values on that graph. Corresponding values are 0 for c, it is a, and for d it is b on t axis. This is the continuous graph representing f of t, and another graph which represents unit step function. This is h of t. Then a product is that represents the same function from 0 onwards, and this portion between a and b becomes 0 or vanishes. Therefore, graph starts from point C, then D, and then E. This point remains as it is. Graph starts from point B. A figure between A and B becomes 0, or the curve becomes 0 or vanishes. This represents a product of f of t into h of t, continuous function multiplied by a unit step function. Its Laplace transform is Laplace of f of t into h of t or u of t as f bar of s. F bar of s means the Laplace transform of that continuous function f of t. Then next, a multiplication of f of t by a displaced unit step function h of t minus e. And to find the value, we take the help of the definition of h of t minus e. There are two values, 0 and 1. For 0, that product becomes 0 for t less than a, and for another value of h of t minus a, 1 into f of t, we get f of t for t greater than or equals to a, and the same we can represent in terms of figure. Again, first figure same as I have discussed in earlier case, a continuous function f of t, and second figure representing a displaced unit step function h of t minus e. Therefore, this one is that continuous function f of t between point A, B, C, D and E, and the corresponding values for C and D are A and B on t axis. This one is unit step function, displaced unit step function. Therefore, graph start from t equals to a. A onwards value is 1, and for values less than a, function value is 0. Therefore, it is h of t minus e. Therefore, when we take a product of these two, the portion before or between a to c vanishes. Therefore, we show it by means of a dotted line, and this is the remaining part of that curve f of t. We show by dark line. Therefore, this much part vanishes, and curve start from C, D, and then E. That part of the curve represents a product of f of t multiplied by h of t minus e. Then fifth case, product of f of t minus a into h of t minus a, both are displaced. Continuous function is also displaced by a distance a, and h of t minus a means it is a displaced unit step function. Again, we take the help of definition. First value is 0, therefore that product becomes 0 for t less than a. Second value is 1 into f of t minus a, we get f of t minus a for t greater than or equals to a, and it is shown in terms of figure like this, that curve of f of t we have to shift by distance a, means each and every point we have to shift towards right by distance a, and the second figure is h of t minus a, means displaced unit step function. Therefore, this is f of t minus a Therefore, this point we call as a dash, new point B dash, C dash, D dash and E dash. Every point is shifted towards right by a distance E. That is the meaning of f of t minus E. And second figure, it is displaced unit step function h of t minus E. Value is 1 for t greater than or equals to E. And for other values it is 0, h of t minus E. Then we find Laplace of this product. Laplace of f of t minus E multiplied by h of t minus E. Laplace is e raised to minus as into f bar of s. For the derivation, I will provide my previous video link. Therefore, watch that videos to see the proof of all these results. Then we take one note to find Laplace of f of t into h of t minus E. The first step is we have to express that f of t in terms of t minus E. Means we have to adjust that term t as t minus A, function of t minus A, and that new function we call as phi of t minus E. Therefore, f of t is equals to phi of t minus A, new function, and then that Laplace of f of t into h of t minus E, nothing but Laplace transform of phi of t minus E into h of t minus E, and as per the previous result or above result, it is nothing but e raised to minus as into phi bar of s, Laplace transform of that function phi of t. Therefore, all about the unit step and displaced unit step function and related important results. Then once again I will combine all these results in one place. Laplace of h of t as 1 by s. Second, Laplace of h of t minus A as e raised to minus as upon s. Then third result, Laplace of f of t into h of t. Third result is for Laplace of f of t into h of t. H or u, whatever you want, you can take. In some books you will find h, in some books you will find u. It is f bar of s. Fourth result, Laplace transform of f of t minus A into h of t minus A as e raised to minus as into f bar of s, and using this we write down the another result. Fifth result, Laplace transform of f of t multiplied by h of t minus A as e raised to minus as into phi bar of s. This is the result as per that note. Then remember all the standard results from this section of unit step and displaced unit step function. Please like my video, share it as well as hype the video, then subscribe to my channel and press the bell icon to receive the notification. Thank you. Thanks for watching.